First thing I want you to do on your calculator, especially if it's mine, because my calculus kids do all kinds of weird stuff on there. Whenever you start graphing in Algebra 2, you should always hit Zoom 6, where it says standard. It sets a grid that's like this, 10 by 10. Odds are, if you're using a yellow calculator, it's not that. So hit the zoom button right here, and then hit number 6, and it'll make a nice 10 by 10 grid for graphing. You should, yeah, yours should be fine because you're not using my calculator. It's the yellow ones that we do all kinds of weird graphing in my calculus classes, so their windows are messed up. Zoom 6 always fixes the window and sets it for algebra. So Zoom 6, 10 by 10 grid. All right? So you need to know what each of these numbers does to the function. We did this earlier in the year, but I would suggest for your table that you let your calculator help you quite a bit, since you have one and you can use it, but you have to know how to use it, so that can be kind of deadly. If you're going to rely on the calculator, you have to be 100% sure you know how to use it. So we're going to go through this really slow. Jake, can you put your computer thing down? So right here, we're going to decide what the plus 5 does to the function. When you mess with x, the x-axis is this one, left, right. So that's going to move it 5 left or 5 right. So 50-50 guess. It's the opposite of what you would think under there. So when you see the plus 5, you're thinking, oh, it's going to move it 5 to the right. It actually won't. It'll move it 5 to the left. If you remember when we did that, so go ahead and write that down. Those of you distance learning, we're going to do 2 of them off the worksheet, and then they're just going to work. Those who took notes are going to continue with this. Those who didn't are going to take notes. So, but all you have to send me a picture of, girls at home, is this first number 1, and we're going to do number 5 together. So then remember, this tells you what happens on the y-axis, and it's exactly what you think. So do you remember when we did absolute value, I said it's the opposite of what you would think when it's the x? So your gut instinct is to say it moves it 5 right, it goes 5 left. Your gut instinct is right for the up, down. -1, do you think that's going to move it up or down? Down. And your gut is right for that one. What's your question, dear?
Your sheet looks different.
It does, but it's the same problem, isn't it?
Yeah.
Yeah. So that's okay. So the next thing I need to do is decide what this number out front does to it. Remember, if it's a negative, it causes it to flip. Do you remember that? But that's not negative, it's positive, so it's totally fine. And by it, I mean, here's the square root of x without any numbers attached to it. This is the graph y equals root x. And it's always centered at 0, 0. When you mess inside, it moves it left, right. The last number moves it up, down, and this will either make it taller or shorter, okay? And the 2, it's like the y's are, it's going to stretch it, right? If it was a half, it's going to shrink it. It's like if I take Jake and multiply his height by 2, he's going to stretch, right? If I do it by a half, he's going to kind of compress and split out the sides. So that's what we call a vertical stretch. And I don't know if he has you right of 2, but I'm going to be just for the, yeah. So now that we described it, you also have to graph it. This is where you're going to use your calculator, but you have to listen for how to use it correctly. All right, first of all, you might just want to go get the vertex on there. Because it goes 5 left, it'll be at -5, -1. But your calculator will show that, but a lot of times, boom. And they want you to put other points on your table. Does that make sense? So what we're going to do is we're going to go in here to our y equals. So it's in the top left. And we're going to go look at our calculators table. I think for you guys this is going to be, oops, sorry. Let me clear that off. So let me go second. I forgot the 2 now. 2, this is touchy. Plus I'm not hitting the right button. Second root x plus 5. So go ahead and enter it on yours. Move it over with the arrow. And then it's a -1. Your calculator's been programmed to do those transformations. It's been programmed to move it 5 left, 1 down, and stretch it out. If you hit graph, you'll see it. So just go ahead and hit graph. See it sitting there? But you need to put the nice hits on your table. And this will tell you where to start your table. And I'm doing it a little different than Mr. Mitchner and Ms. Barrios. So if their way in the notes makes more sense to you, you do that. But my job is to kind of sometimes give you alternatives. Does that make sense? So I'm going to have you go to your table. So you see where it says above graph, it says table? Your calculator will make a table. All right? So you're going to go second table or second graph. Do you see all those ugly numbers on there? Does yours look ugly, Jackson? See all those ugly Y values?
Where do you type in for the graph to show all that stuff? Where do you type it?
Y under Y equals. You type that in. Did you type it in yet? I'll wait for you because I'm only doing one. Did you get yours typed in? Did you get yours typed in too? All right. And then to see the graph, I'm not going to graph it yet though, but I just want you to see how our vertex is, it moved it 5 to the left and 1 down from 0. So it did what it should have done. To go see the table, above graph it says table. The calculator will make a table for you, but you have to really make sure that you get what you need off of it. And here's the most important part. Are you watching? Start here at -5. So mine's at -4. Do you see how -5 gives you a really nice number? You see that? -1. Anything past that, by the way, is going to say error because the vertex, it starts and it goes forever this way. It can't go to the left. So we're starting right here. Yep.
Mine says error at -5.
Then you must have typed it in wrong. Because yours look, and I'm going nice and slow just on one of them. So let's see what yours looks like typed in. Oh, you forgot to move the arrow over. So your -1 is under the root. Once you hit that 5, you have to get out from under the root by using this arrow. So here, I'm going to clear it and enter it again. Because again, I'm going to teach you to work your calculator, but you have to know how to work it then. Does that make sense? So we're going to go second, then we do the root, and then this is where yours went wrong, Jake. It's x plus 5. You need to move it out from under the root by hitting that button. And then it's -1. Your 1 was under the root. Then we looked at it with the graph. And then we need to fill in the table. But we'll let our calculator help you. The most important thing is to start right after those errors end. It'll always be right here. And then you're going to pick off the first 4 nice numbers. And you'll get the 4 that Mitchner and Ms. Barrios taught you how to get by hand. Does that make sense? So -5, -1. Here's a nice one. -4, +1. Icky poo. Icky poo. Here's a nice one. Right? Ick. You need the first 4. How many?
4.
4 nice ones where it doesn't have all those decimals. No, and there's my last one. They could be like 2.5, but you don't want any of these where, look it down on the bottom. Look at how ugly that number is. Can you see that? You don't want that. Who wants to graph that, right? If it was 4.5, you're fine. But all these long decimals, although they're on the graph, we don't want to plot those. So again, I'm going to tell you where you start. You start after where it says error. It'll always be at this value. So it's pretty easy to find where to start on your graph. You pick the first 4 that are nice. Do you know what I mean by nice, Parker? Yeah, like here. Here's nice. This one's nice. Ick, ick, nice. Ick, 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 nice. Those go here. Those get plotted. So I do -5, -1. And I do, oh, that was a -4, sorry. A -4. My graph moved over. A -4, 1. A -1, 3. And a 4 over and 5 up. Was that right here? And then you just shoot it out like this. If you want to check, Tanner, are you doing it with us? You just.
No, I'm doing my notes
Oh, okay. Are you writing them down? Why not?
because I don't have my sheet
Oh.
on my car.
I have an extra grabbed one just for that purpose. So there it is. Now, Tanner, if you, not Tanner, Jackson, if you want to check if your graph is good, then just hit this graph button and ask yourself, does mine look like my calculator's? And it totally does, right? Domain and range. I think for you guys, what I want you to do is go like this, X, Y. Domain is always about X, range is always about Y. The easiest thing I think to do is picture lines going through the vertex like this for your domain and range. Okay, is that going to the right or to the left? To the right or to the left?
Right.
To the right, it's greater than. Is it going up or down? That's greater than. Okay, so that's how you decide the signs. It's going to be, if it was going to the left, we do less than. If it was going down, we do less than. So I think it's easiest to just kind of picture it across hairs here and go, okay, if it was going like this, it'd be going to the right and down, and this one would be less than or equal to. Does that make sense, Betsy? It helps. Now you got to kind of decide from what. These two, the vertex tells you I'm always to the right of -5. It's always this way, and I'm always above -1. It's this first point on your table that tells you that. You guys are really listening. I think I kind of want to do one more. Unfortunately, I don't have, let's go to the next one on there. Let's go do number 2 together, and then I'll do number 5. All right, so we're going to go do number 2 together. I'm just going to have to rewrite it. All right, and I'm going to have you guys sort of, I'm going to try to stay off my calculator so that you're actually doing it. All right, so the first thing to do is to do the transformations, okay? So we have to decide what these numbers, so we'll be actually writing 4 things down. There's a negative and a 3, so let's start in there with the x. What does that -2 do to it?
To the right.
To the right, exactly what you would think it would do. Actually, the opposite, I mean. 2 to the right. Then let's go over here, Betsy, +3. Do you think that moves it up 3 or down 3? Up 3. Yep. And don't worry about this negative right here. Look at that 3 and me making Jake stretching him 3 times his height. It's a vertical stretch. That was a half. We call it a compression. So we're going to say vertical stretch. We good so far? And put
So
up
that
3.
was a fraction and decompression.
Yes. Now, what do you think about that negative? Do you remember what that will do to it? It's way back to our absolute value when we used to have these guys. Do you remember what the negative did to it? It made it go from this. It flipped it over. But I think they want you to write x-axis reflection. Does that sound familiar from your notes, Jackson?
Yeah.
All right. It's the negative that causes that. That's why I didn't write it on number 1 because it had a +2 in front of it. Okay? So the negative just flips it over. So let's take a look. First of all, see if you can work your calculator. Okay, you're going to use your calculator to get your table. And then we're going to graph it. And then we're going to hit graph. So I want to see if you remember. Again, because if you can't remember, then you have to do it the long way. So it's a little deadly teaching you a shortcut, but if you remember it, it's pretty awesome. Remember, we enter it right here. If you click Get Started, it's always that top left corner. Clear out what was there. Don't forget, Jake, to move out from under the root after you hit that 2 with the arrow. So you might want to look up, make sure yours looks like that. Remember where I told you to start your table. We need the 4 first nice points. They start after the words error. Think you got it? Where did you start your table, Jackson?
2, 3.
Yes, that's the vertex, and that also is going to control our domain and range. So this is a really important point that you get that on there first. If you miss it, you're going to get a lot of answers wrong. So you just got to be really careful on your calculator. 2, 3 is the first nice one. The next one is 3, 0. Then I've got, and again by nice, I'm looking at these because I've got to graph them. I don't want to graph negative 1.2426402611193, right? And your teachers are going to teach you a way to find these without using your calculator, which is totally fine, but I just found my next nicest one. At 6, I can easily plot a negative 3. Agree? And then accidentally. Can you tell me what the next one was, Jackson?
11, negative 6.
There it is. What do you do with those? You go plot them. You're going to go to 2 over, 3 up, 3 over, 0 up, 6 over, 3 down, and then at 11 you're going to be way down at negative 6. It starts from here. This guy's in control. So you connect dot to dot. I'm going to make a bigger dot because I missed it. Okay. How's that for working your calculator? Do you think you got it? All right, well, the next thing is that domain. It's always X, it's always Y. It's like alphabetical order. Picture there being crosshairs through the vertex. I think that's the easiest thing to do. Do you know what I mean by crosshairs? I did it in red. Am I to the right or to the left? Right, so that's greater than. Okay. Is it down or up? Down, so that's less than or equal to. And then you might say what? From the vertex, right? The X was at 2 and the Y was at 3. What do you think about that? We good? Now I want to do one more though, especially for the girls at home. I want to do number 5. I don't remember the directions for number 5 though. What were you asked to do? Can you read it? I just screenshot the problem. Number 5 on the back.
List the transformations in each function and state the domain and range.
Okay, so we've got transformations, domain, and range. So this one, when they look like this, you have to factor out that lead term. So what you need to do is take 324 on your calculator, and I need you to divide it by 81 for me.
4.
4. Okay, so this would be plus 4. And then this would be minus 5. So the first thing you do is divide that 81 out of both of them. And do you guys know the square root of 81? What is it? 9. That's going to come out front. It's going to cause a major vertical stretch. Imagine me making him 9 times as tall, and I don't give him any food. I just stretch him. Like, he's going to be way up there, correct? So this is going to become the 9 out front, and then the x plus 4 under there, and then the minus 5. So you guys see if you can tell me the 3 transformations you're going to write down. It's not going to reflect, because it's not a negative 9. It's going to go to the left, 4, down 5.
So for
Yeah.
the one that's not in square root, that one's like how it should be.
This one?
No, for the negative 5.
Yes, it's exactly
That
what
one's
you
not
would think.
full now.
Yeah,
That's weird.
5 down, just like you said. Yep, so you're right. It's 4 left. It's 5 down. Will it stretch or compress?
Straight.
Oh, super stretch. So vertical stretch. And Betsy, how do I know that it's not going to reflect over the x-axis? Because I wrote that for the last one. But this one, I'm not going to write that. Do you remember? What caused it to flip over? And it did. If you look, my graph went down instead of...
It's a negative.
It was the negative, yeah. This doesn't have a negative in front of it, but if it did, Parker, if there's a negative right here, you'd also write x-axis reflection. All right, what else were you supposed to do? Domain and range,
Yeah.
right? So let's go over here. Remember that 4 left and 5 down will get you your vertex. So there's your vertex right there. So you're gonna do x. Actually, go look at this on your graph too. You can go look at this on the graph if you want to on your calculator. If you're like, I don't know if it goes right or left or up or down, go look on your calculator. Go graph it. Let's go do that. We've got 9 second root x plus 4, move it over, minus 5, and go look at the graph. There's our vertex at -4. Boy, did it stretch up. Look at mine, it's like shooting way up there because of that 9. So picture these, Parker, right? Right through that vertex right there. Will it be greater than or less than? It's to the right. Greater than or less than? It's up. And then of what? That vertex. Now I hope you're going to make a decision because your teacher's going to kind of re-go over how you find the points on the table without using the calculator.
The commissioner was teaching us like
I don't-
Yeah, and you decide what you like better because I don't want to screw you up, but I like to give you a second sometimes.
I don't understand why they would use that when this is way more easy.
It depends. Some people, if you don't know how to use that, you know what I mean?
Or if you don't have one.
Or if you don't have one, so yeah, I get it, but they are allowing a calculator on this next test,
Well, then that should be.
but you just need to make sure you know how, like, 2 weeks from now, are you gonna remember where to go on that table? That's what's dangerous with the calculator. So we're gonna decide if we need to do it by hand. Once we get closer to the test, I'll say, I think we need to do these. Okay. All right, you guys can head on out. See you later. Have a good weekend.
You too.
You heading out, Jake?
So, that whole calculator thing's a lot better than what we were doing yesterday.
What'd you say?
The whole calculator thing's a lot better than.
If you remember.
It's not. It's not.
That's the danger.
I don't think it's too bad.
All right, I gotta go grab my lunch.
Again,
You too. Lots of hockey this weekend?
yeah, we can, yeah. We're at home. That's important.
You good?